Now, this is a regression equation, and it says the average length of time a patient stays in the hospital continues to decline. The table below gives you the data for certain years. Let x be the number of years after 1970. So x equals 0 is 1970. And y be the length of time in days. And so they says align the data. Well, 1970 is 0. 1980 is 10. 1990 is 20 years after 1970. And 2002 is 32 years after 1970. And if I want to do a scatter diagram, it looks like that the highest this goes is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. And then 0 to 32, let's take these guys in 10. 10, 20, 30, 40. So at 0, it's 7.8. At 10, at 0, it's 7.8. And let me fix that. At 10, it's 7.3. At 20, it's 6.4. 1, 2, 3, 4, 5, 6, and over and up a little bit. And at 32, so it's a little bit bigger than 30. 1, 2, 3, 4. It's almost 5. So it might look something like that. Use your graphing calculator to find a line of best fit. So I'm going to take my calculator and go to Stat, Edit, and now I need to put in my data: 0, 10, 20, 32. And I don't need the next two, so I'm going to delete those. And 7.8, 7.3, 6.4, 4.9, and then delete these two. So I want to do a linear regression on that. So Stat, Calculate, Linear Regression, and if you're using something other than the color one or the fancier one, you don't have this. So what I do is just go down to Calculate, and there you go. So, whoops, I picked a quadratic regression, wrong regression, and wasn't looking. So Stat, Edit, Stat, Calculate, Linear Regression. Let's try this again. And that looks better. So it's y equals ax plus b. A is negative 0.09. B is, that's the y-intercept, is 8.01, and then there is r. That tells me how good the fit is. So this is state your answer to 2 decimal places. So to 2 decimal places, I have that y equals negative 0.09x plus 8.01. And the correlation to 5 places, and it's negative 0.98263. And how do I know what kind of fit it is? It is pretty good. Not perfect, because remember, plus or minus 1 is a perfect fit. And this is because I have 1 9. The more 9s I have, the better the fit. Using the details in this problem, interpret the slope of the line. The slope is negative 0.09 over 1, really. And if I want to interpret it, the y value is time. The y value is days, or time, days, and the x value is years. And so what this is telling me is it is over 1 down 0.09. So this says for every additional day after, or additional year after 1970, the number of days decrease by 0.09. If the trend continues, what will the number of days patients stay be in 2010? 2010 is how many years after 1970, and so X happens to be 40, so it's 40 years. So if my model is okay, this says the number of days, or the length of the stay, is going to be negative 0.09 times 40 plus 8.01, and that is going to come down to be 4.82 days. Don't forget your units. In what year will the number of days a patient stays in the hospital be 3 days? 3 days, that means that y equals 3. So I'm going to look for the x value. So this would say negative 0.09x plus 8.01 equals 3. Negative 0.09x equals 3 minus 8.01. Negative 0.09x equals, and negative 5.02. So that x is equal to negative 5.02 divided by negative 0.09, or x is equal to 55.8. And this is years after 1970. So if you use the 55.8, you have to include years after 1970. But it says in what year. That would be 1970 plus 55.08, or 55.8, excuse me, which is going to turn into 2025.8. So that says during the year, you're not complete, of 2025 is when you're down to 3 days.